Hi guys, welcome back to Pyro versus YouTube channel where curiosity meets the code. Today we'll be discussing about how to create a spirograph drawing with turtle graphics. But before that, we'll be checking the packages pre-installed in my system. So the first command that I'm going to execute in command prompt is pip list, where you can see all the packages with the versions so it can give a look about what package is what version and update it accordingly. So you can take a look onto your packages. If not installed, please do install it. You can just Google how to install and there will be a command for that to execute in command prompt. Another command to check for all these is pip freeze, which gives a similar output where packages with the version will be mentioned. So let's get started with the code, starting with importing the necessary libraries for the program, which includes Turtle and Math. So Turtle is used, which provides a graphical library for creating drawings and animation, and Math function is which will provide mathematical functions and constraints. So moving on to the program. We have the first function in the program as def spirograph, and then second one is def main, and lastly we have the execution part. So let's go with each of the functions. So starting with def spirograph. So this line defines a function named spirograph that takes four arguments, which is r, the radius of the large circle, small r, radius of the smaller circle, d for distance of the pen from the center, and t for the turtle of the object using. So I've mentioned all the abbreviations down, and we have t dot pen up, t dot go to r minus r comma 0, and t dot pen down. These lines move from turtle to the starting position for drawing the spirograph. The pen up method lifts the pen up to go to method moves the turtle to the specified coordinates, and pen down method puts the pen down. Start drawing, and we have for theta in the range 0, comma 36, 361 into 4. This line starts a loop that iterates over the angle of 0 to 360 degree multiplied by 4. This range covers a full circle, which is a 360 degrees 4 times. And we have theta is equal to math dot radius theta. This line converts the angle theta from the degree to the radius using the radians function from the math module. And we have x is equal to r minus r into math cos theta plus b into math cos r minus r into theta divided by r. This line calculates the x coordinate of the current position of on the spirograph using the parametric equation for the spirograph, and we have y is equal to r minus r into math sine theta minus b into math sine r minus r into theta divided by r. This line calculates the y coordinate of the current point on the spirograph using the parametric equation for a spirograph, and we have z is equal to r minus r into math dot tan theta into d into math dot sine r minus r into theta divided by r. This line calculates the z coordinates for the current point on the spirograph, but it seems unnecessary and may be an error. It's not typically used in the drawing of spirographs. And we have lastly t dot go to x comma y. This line moves the turtle to calculate the xy coordinates drawing the spirograph as it moves. Moving on to the next function, which is def main. So let me just select it. So firstly, we'll start with df main. This line defines the main function which serves as an entry point of the program. The explanation will continue in the next part. Screen is equal to turtle dot screen. This line creates a screen object named screen, which represents the window where the turtle graphic will be displayed. And we have screen dot setup width is equal to 800, height is equal to 600. This line configures the dimension of the drawing window to have a width of 800 pixel and a height of 600 pixel. And we have screen.bg color black. This line sets the background color of the drawing window to black. And we have t is equal to turtle.turtle. This line creates a turtle object named t, which will be used for drawing the spirograph. And we have t comma speed 0. This line sets the drawing speed of the turtle to the fastest possible speed, which is 0, indicating that the turtle should draw as quickly as possible. And we have t dot color as cyan. So this line says the colors turtles pen color to cyan, and we have r is equal to 150, small r is equal to 7, d is equal to 10. These lines defines the parameter of r, small r, and d for customizing the spirograph. These parameters controls the sizes of the circle and distance of the pen from the center. And we have spirograph RDT. This line calls the spirograph function with specified parameters to draw the spirograph using the turtle t. And we have screen.main loop. This line starts the event loop of the screen, allowing the program to respond to user interaction and events. The program will remain in the loop until the drawing window is closed. And the last part, we have the execution part, which is if name is equal to main. This line checks if the script is being run directly as a main module. And we have name with main with the braces. This script is being run directly. Main function is called to start the program. So let's just quickly take a look at the output of the program. So as usual, we are going to go where the program is stored, copy the name of the program, and Python cmd, sorry. Then we have Python space file name dot py, and you can see there's a cyan color pen which is drawing, which each point has been specified. So that first one was taken into the bigger R radius, and then it gets smaller R radius. And this keeps continuing. Thank you so much for watching. If you have learned something from this video, please do like, share, and subscribe to our channel. Thank you.